20 years after graphene first captured the scientific world's attention, researchers just unlocked what might be its most mind-bending secret yet. A groundbreaking collaboration between scientists at the Indian Institute of Science (IISc) in Bangalore and Japan's prestigious National Institute for Materials Science has achieved something that sounds almost too fantastical to be real. They've successfully observed electrons behaving like a perfectly frictionless liquid within graphene's atomic structure. For those unfamiliar with this wonder material, graphene consists of nothing more than carbon atoms arranged in a single, ultra-thin sheet. Imagine peeling off the thinnest possible layer from a pencil's graphite core. Despite its simple composition, this material has consistently surprised researchers with properties that seem to defy conventional physics. But here's where it gets fascinating. The team discovered what scientists call a quantum fluid of electrons. Think of it this way. Instead of electrons moving individually through the material like cars on separate lanes of a highway, they're flowing together as one seamless, frictionless stream, almost like water rushing through a perfectly smooth pipe. This extraordinary behavior follows what researchers describe as a universal quantum number, essentially a fundamental mathematical rule that governs how these electron rivers flow. What makes this discovery particularly remarkable is the timing. As one of the study's co-authors marveled, it's amazing that there's so much to do on just a single layer of graphene even after 20 years of discovery. This statement highlights a curious paradox in materials science. Sometimes the simplest structures harbor the most complex mysteries. The implications could be staggering for future technology. When electrons can flow without any resistance or friction, we're potentially looking at revolutionary advances in everything from ultra-efficient electronics to quantum computing systems that could make today's fastest computers look like pocket calculators. But here's where it gets controversial. While this discovery sounds incredible on paper, skeptics in the scientific community often question whether such quantum phenomena observed in laboratory conditions will ever translate into practical, real-world applications that actually benefit society. After 2 decades of graphene research promising to transform everything from smartphone screens to space elevators, many are still waiting for these miracle applications to materialize in their daily lives. This raises a thought-provoking question that deserves honest discussion. Are we witnessing the next breakthrough that will finally unlock graphene's commercial potential? Or is this another fascinating but ultimately impractical laboratory curiosity? What do you think? Will quantum electron fluids in graphene actually change our technological landscape? Or are we getting caught up in scientific excitement that may never reach our pockets?